Sweet. Okay, this should be another quick one. I'm pretty much just going to go over non-right angled trigonometry, but not the stuff where we talk about like stuff with the unit circle and stuff like that. Pretty much just the sine and cosine rule. So in order to do that, I'm just going to quickly recap what the sine rule is. I feel like this needs an underline. I thought I'd draw the triangle so I'm not sitting here embarrassing myself trying to connect them, but this should be quick. The sine rule only works if I've got A and the angle opposite, and sorry, the side opposite, and B and the other side opposite. You can only use the sine rule if you've got 4 pieces of information, and those 4 pieces of information just happen to be opposite each other. So you just need to be able to draw that. I've seen some people draw like that, that's perfectly fine as well, but I just draw, maybe I'm going to do it nice. I generally just draw that. If I can draw that around all my information, then I know that I can use the sine rule. The sine rule goes A, sine A, equals B, on sine B, and then if you wanted, C on sine C, but that part's not really necessary. Okay, and that's where we use the sine rule. The cosine rule only works if I've got either all 3 sides or 2 sides, so B and C, no, A and B, and the angle that's in between them, so C, so that one. Or if you put all 3 sides like I said. Now obviously there's 2 cosine rules. My hair is annoying the hell out of me, get out of my face. Okay, so if you're trying to find, I guess, C, then it's C squared equals A squared plus B squared, so I just remember it as Pythagoras with a little bit extra. Minus 2AB cos C. And some people notice that when this is 90 degrees, this whole thing becomes 0, which means this thing cancels out, and a right angled triangle just uses Pythagoras, and that's what that is. That's the cosine rule for when you've got, when you're missing a side, when you're missing an angle, it's cos C equals A squared plus B squared minus C squared all on 2AB, and that just comes from the above formula rearranged. So they're the 2 cases. Now the sine rule, when you're trying to find an angle, you just flip these, so you take the reciprocal, but it doesn't really matter, you're doing the same thing, it's just a little bit easier when you're trying to solve. So the sine rule, you need to have opposites. The cosine rule, you need 2 sides in the included angle, or all 3 sides. And that's kind of it. I'm just going to go over 2 examples where it doesn't really tell you what you have to use. So in this case, I'm looking for K, which is the side. I always check for the sine rule first, and then think to myself, okay, well then I'll need the cosine rule as well. So I try and draw my thingos. Yes, I'm covering. Yes. Oh no, I'm not. Oh. Okay. So what I tried to do there was go like this. Oh, can't do that, can't do that. Okay, so that means I must be using the cosine rule. Okay, let's check for that. I've got 2 sides in the included angle, sure, so now I can use that. So then I'll just go ahead and label everything. So I call this C, call that C, call that A, call that B. Now the reason I didn't just snip this from the textbook is because I don't like the way they write the cosine rule. Okay, so for A, I just like writing it out, so C squared equals A squared plus B squared minus 2AB. That's very loud. Let's go heavy music, screw it. Now, my information, so C squared is K, A squared is 8.4, that's around about 82, 63, 889. Then I'll take the square root. That's approximately 8 meters. Okay, so literally it's just shoving into a formula. As long as you know which formula to use. If I try to use the sine rule here, then there we go. So again, I'm trying to find theta, Now I check for the sine rule, so I go, can I draw opposites? In this case, yes I can, so I'm going to use the sine rule. Okay, so I'll call this, doesn't really matter, so just call 1A, 1B. So A, B, B, A. Well, I'm trying to find an angle, so I'll flip it. So sine A, sine B, B. I like using this. That's annoying me. Sine A is sine 57. A is 9. Sine B is theta. B is 8. Generally you call A or sine A what you're trying to find, but in this case I haven't done that. Okay, now I care about my triangle, now I can start rearranging. I'm going to move this 8 up here, so I'm going to have 8 sine 57 9 equals sine theta. Let's do all this in one step. Just going to swap everything. Theta equals sine inverse. If these are nice numbers, then I might have been able to find an exact value, but I can't, so therefore I'm going to use a squiggly line, and I'm going to get 48.207. Then I press the bubble button, and that's 48 degrees and 12 seconds. That's literally it. So I just want you to be able to distinguish between the cosine rule and the sine rule, and what you need to use in what situation, and be able to use it, I guess. There is the exercise. I have put some questions up there. You'll see in the extension there's a puzzle sheet attached, so if you don't really want to do the textbook exercises, you can just do the puzzle sheet, which is just like 5 questions or so, and there's like a puzzle in it. And there's hard questions in the Power Plus, which do involve some of the angles of any magnitude, which is like the unit circle and stuff. So if you'd be keen to do that, then by all means, but I'd be surprised if anyone got all of them correct, because they are quite hard. But power to you if you'd like to try.